7th graders, this is Miss Myers with a review of the Unit 3 study guide. You should have completed the study guide, and now we're going to go over the answers. Some of them we're going to elaborate and talk a little bit more about, and others I'll just give you the answers. So as you're going through the video, I'd like you to make corrections to anything that's incorrect, and if it's correct, just check it. So let's go ahead and get started. Okay, the first problem, we're translating. We're drawing a line from each verbal expression to its algebraic expression. So over here, make sure you look at all these words to help you. And we'll go ahead and get started. So the quotient of x and 5, quotient means to divide, so that's going to be your answer. 6 less than x, remember, it's minus 6. 6 less than x. So the minus 6 is actually going to come after your x. I'm going to try that again. So this is minus 6, and this is x. So if it's less than something, you're actually going to take it after. So it's 6 less than x. And so 6 less than x would be right here. Next one, 10 added to the product. So if I'm adding 10 to something, and I'm adding it to the product, remember product means to multiply. I'm multiplying 3 and x. So I'm going to add the 10 to it, 3x plus 10. So that's my answer for that one, 3x plus 10. The next one, 8 added to the product. So again, that's going to be a plus 8. We're adding 8 to the product of 2 and x. So we're going to take this plus 8 and we're adding it to the 2x. So that one is going to be right here. Notice here it's reversed because the commutative property allows us to do any order, but only for addition. The next one, 1/2 of x added to 8. We're taking half of x and we're adding it to 8. That's right there. 6 decreased by x is 6 minus x up here. 2 times the difference of 8 and x, okay? The difference we're going to put in parentheses, and we're multiplying that by 2. And so this one up here is the answer. And finally, the product of x and 5. Product, remember, means multiply. So we're going to take, algebraically, we don't write 5x or x5, even though the x came first in the problem. Oh, let me scroll this down. Even though the x came first in the problem, we actually put the 5 in front when we're dealing with our algebraic expressions and equations. So that one's going to be right here. All right, so study vocabulary. If you're getting any of those wrong, look back at your vocabulary and study those. All right, let's move on. Now we've got modeling equations. Get rid of this line here. So modeling equations, if we start with the first one, we have on the left side, we have, if we count those, we have 1, 2, 3, 4, 5, 6, 7. And then on the right side, if we look at our key, we have 2 x's. And then we have a -1. So that's -1 or plus -1. So again, this is 7 is equal to 2x minus 1. The next one, we're actually going to find the value of x. So for this, we're going to write our equation, 2x, and those are negatives, so it's -4. And then we're going to count these out, 2, 4, 6, 8, 10, 12. We're going to add 4 to both sides. That cancels out. So then we're going to get 2x is equal to 16. And if we divide both sides by 2, I'm going to just bring it over here. 2x is equal to 16. We divide both sides by 2, and x is equal to 8. So again, we read the model, and then we came up with the expression. All right, let's take a look at the next examples here. And we're looking for the set of algebra tiles that represents x plus 1 is equal to 5. And for that, we're looking for one x value, and we're looking for 1 unit, and then 5 on the other side. So our x plus 1 we have on this one, and that's the only one we have it. So this one is actually x plus 2 equals 5. So that's not going to be right. This is x plus 7 equals 5. That's not correct. And this one is x plus 9 is equal to 5. So the correct answer is right here. We have 1x plus 1, and we have 5 on the right. The next one, we're looking at these emojis. So the first ones here that we see are x's. So we're going to say this is 2x because we have 2 of them. And then we have 1. So we're going to add 1 to that. And then on the right side, you see we have these sad faces, which are negatives. And we have 4 of them. So that's going to be -4. So the correct choice is this. Let's look at our next problem. We're going to solve and then check some equations. So remember, our goal is always to isolate our variable. We're going to draw a line down here. And the first thing I'm going to do is subtract 7 from both sides. And then the right side cancels out. I bring down my 2x. 9 minus 7 is 2. I'm going to divide both sides by 2, and 1 is equal to x. So now we're going to check it by putting in 1 for x. 9 equals 7 plus, so we're just rewriting this, putting in this value. So 9 is equal to 7 plus 2 times 1. 9 is equal to 9, so this one checks. Now the next problem, if we take a look at that one, you're going to see it's a little different. We're actually going to undo the division first by multiplying both sides by 2. Because remember, we follow GEMDAS backwards. When we're solving an equation, we undo what's been done to the variable. And if we look at the variable here, it's been divided by 2, and we also might have -4. We're going to undo the divided by 2 first by multiplying before we do the x minus 4, because the x minus 4 is, even though there aren't parentheses there, it is grouped by the fraction bar. All right, so we are going to multiply both sides by 2. We have x minus 4 equals -22. We're going to add 4 to both sides, and this cancels out, and x is equal to -18. We're going to put -18 here in our check and see if that's -11. And if I put that into Desmos, -18 minus 4 divided by 2 is -11. So -11 is equal to -11. Next problem, this time we have a fraction next to our variable. And remember, when we have a fraction, we're trying to get 1x. And the multiplicative inverse property says if we multiply a fraction by its inverse or reciprocal, we get 1. So we're going to multiply. We want 1x, so we're going to multiply both sides by 3/2. This side is going to cancel out, so we get x equals, and then it's going to be 9 times 3 over 2. So it's going to be 27 over 2, which is equal to 13 1/2. Whoops. And now we're going to put that into our inequality, our equation. 2/3 times 13 1/2. We want to see if that's 9. And using our Desmos, we'll see that it's right. 9 equals 9. So you're going to use Desmos on this part to see if you get this answer. All right, let's go on. We've got another one here. We have 2/3 x equals 9. It looks like we have a repeat. Oh, I already did that one. All right, so let's move on to the error analysis here. So we're going to look and see what has been done, what the mistake is in that problem. And if you look at this, if we're adding here, the mistake is that when I'm going to do this problem, if I was doing this correctly, if I had negative 1.5, I'm just going to write it over here, plus k equals 8.2, the way we get rid of negative 1.5 is by adding a positive 1.5. So that's how you do it correctly. So let's look at the answer over here. Let's see what they did. They added a negative 1.5. So that was the mistake. Okay, so I would describe the error as you need to add 1.5 to get rid of, because we're trying to isolate the variable, negative 1.5. All right. Next one, we're looking for all of the equations that have a solution of x equals 2. So we're going to solve the equations. This side, I'm going to subtract 4 from both sides. This cancels out. Again, we decide what to do based on the side with the variable. This side has the variable, and whatever we do here, we're then going to do on the other side. So now we get 3x is equal to negative 6. We're going to divide both sides by 3, and we're going to get negative 2 equals x. So this would not be an equation that has a solution of x equals 2. So I'm going to carry on to the next one. I'm looking at the side with the variable. 2x plus 1 equals 5. And I'm going to subtract 1 from both sides. This cancels out. 2x equals 4. Divide both sides by 2. X equals 2. So this is one that I'm going to circle. Okay, now I'm going to get rid of this over here. So now we have 1/4 x equals 8. So remember, whenever you have a fraction next to your variable, like we do here, to get rid of it, we're going to multiply by the reciprocal, which in this case is 4/1. Multiply both sides by 4 wholes, 4/1. This cancels out, and x is equal to 32. So that one would not be one we circle. All right, let's look at the next one. Now I want you to notice from this, we have a negative x. So when we get to the end of this, we're going to have to do something to make that positive. So here I'm going to subtract 4 from both sides. I'm going to undo addition. This cancels out. I get negative 2 equals negative x. So at first you might say, well, the answer is negative 2, and we're looking for a solution of positive 2. But that says negative 2 is equal to negative x. So what we actually have here, what we have is negative 1x, right? Because you have 1x. And if I want to get rid of the negative 1 or the negative, I'm going to divide by negative 1. So if I divide by negative 1, negative 2 divided by negative 1 is 2. 2 equals x. So that also has a solution of x equals 2. All right, let's go on to our next problem. So now we're looking at word problems. So make sure you read over these tips and tricks. We're highlighting, writing our equations. We have to figure out, does it make sense? And then really important, if I go back here to the beginning, we're trying to figure out the variable. So if we read this together, Shanice is thinking of a mystery number. She cuts it in half and then adds 5. The result is 24. Okay, so here the mystery number, it's something we don't know, so let's use n. Okay, she cuts it in half. So let's think about what cutting in half would be. Cutting in half would mean we're going to divide it by 2, right? And we're going to use that division bar. And then we're going to add 5. So this says she's going to add 5 to the number. And then we know that the result is 24. So let's put all that together. Shanice is thinking of a mystery number. She cuts it in half. She divides it by 2. She adds 5. And it says the result is 24. So there you go. So again, we're just translating what's here into an equation. And the correct answer, of course, is this one here. And they used x for a variable, but it doesn't matter. And the bonus, to find the mystery number, I can solve my equation. Subtract 5 from both sides. Cancels out. N, oops, let's move this up. N divided by 2 is equal to 19. So now we want to undo the division by 2 by multiplying by 2. And so n here is equal to 38. That is the mystery number. And we can check it. 38 divided by 2 plus 5. And see if that's 24. 38 divided by 2 is 19. 19 plus 5 is 24. So this would be a check. All right, now we have a word problem. Michael is collecting shells from the beach. He begins with 14 shells, so that's how many he has. And he's going to add 3 new ones per day. And we're trying to figure out how many days it will take for him to have 80 shells. So we're trying to figure out, they've already told us the variable is d. So d is equal to days. And he starts with 14. Right? It tells us in the problem he has 14 to begin with. And he's going to add 3 new ones every day. So that's our variable we're going to use for that. And it's per day, so that's multiplication. And he's trying to get to 80 days. So we want to find out what is going to be equal to 80. So again, I'm going to put all that together. I'm going to grab the 14 that he started with. And then he adds 3 of them per day. Okay, so we've got the 14. We've got the 3 times d, 3 per day, and then that's going to be equal to 80. Now the question is, what do we put in between the 14 and the 3d? Well, it does tell us in the problem that he adds 3 of them. So this is going to be an addition problem. So here is your equation. The bonus, we're going to try to figure out how many days it takes. So 14 plus 3d equals 80. We're going to subtract 14 from both sides. This cancels out. 3d is going to be equal to 66. Divide both sides by 3. And d is equal to 22. All right, we're going to go on now to solving inequalities. So we solve inequalities just like equations, except for 2 major differences that we've learned about. They have infinite solutions, and whenever we multiply or divide by a negative number, we need to flip. So the first one here, we're isolating our variable just like we do with equations. I'm going to subtract 7 from both sides. I'm going to undo the addition. This cancels out, and 2x is less than 12. Now I'm going to undo the multiplication by dividing both sides by 2, and x is less than 6. The next problem, 10 is greater than or equal to negative x plus 8. So again, we're trying to isolate our variable. So we're going to subtract 8 from both sides. This cancels out. 2 is greater than or equal to negative, and I'm going to go ahead and put my 1, right? Because it's 1x. So we're going to use that negative 1 to get a positive x. So in order to get rid of that negative 1, because it's negative x, we're going to divide both sides by negative 1. When we do that, on the right side, it cancels out. On the left side, we get negative 2. So we have x and we have negative 2. But remember, when we multiply or divide by a negative, which is what we're doing right here, we need to do what to the sign? That's right, we are going to flip the sign to less than or equal to. So that's the answer. You could also write this, x is greater than or equal to negative 2. Both of those are correct. All right, next one. We're going to add 4 to both sides. This cancels out. 2x is greater than negative 12. Divide both sides by 2, and x is greater than negative 6. And we didn't flip here. We didn't have any multiplication or division by a negative. Next problem we're going to solve, and we're also going to pick possible solutions. So let's go ahead and get started. Put our line down the middle. We're going to subtract 2 from both sides. So 3x is less than 6. Divide both sides by 3, and x is less than 2. If x is less than 2, then the possible solutions would only be negative 7 and negative 6, because all of the other numbers are greater than 2. Next problem, we have that fraction again. So to get rid of the 2/3, we're going to multiply by the reciprocal. So then the 2/3 cancels out, and we get x. And then on this side, we're multiplying 10 over 1 times 3 over 2. So that's going to be 30 divided by 2. And 30 divided by 2 is 15. If 15 is greater than or equal to x, that means that x is less than or equal to 15. So this time we're going to choose all solutions that are less than or equal to 15. So we can choose 15 because of the equal to. We're going to choose 10, negative 10, and negative 30. The only number here that's not less than or equal to 15 is 30. Next problem. X divided by 5 minus 3, which by the way is quotient. X divided by 5 minus 3. We're going to add 3 to both sides. This cancels out. X divided by 5 is less than negative 2. We're going to undo our division by multiplying both sides by 5. And then x is less than negative 10. So now, this time we're not going to include negative 10 because it's not less than or equal to, it's just less than. So we're not going to include negative 10. That would be if it was less than or equal to, but it's not. We're only going to include here negative 15. All of these others are larger than negative 10. All right, now we're going to look at some graphing. So we have x is greater than 2. And your graph is going to be an open circle to the right. So some possible solutions are going to be 3, 4, 20. Okay, multiple solutions here that are greater. But notice I did not include 2. So this is saying x is, oops, let's go back here. I got my sign wrong. I was looking at the first problem. This is actually x is less than 2. So less than, open circle to the left. Sorry about that. And the numbers that are less than 2 would be 1, 0, -5. These are all numbers that would satisfy that inequality. All right. Sorry, that looks a little funny. I'm using my iPad at the same time, and it duplicates what I write. All right, next one. This is going to be x is greater than or equal to or equal to 2. So this time it's going to be a closed circle, and it's going to include values to the right of 2. So we are going to include 2 this time, and 7 and 100. These are all possible solutions. Anything that's greater or equal to 2. The next one, we have x is less than or equal to 2. Okay, so this time it's going to be closed circle again, and we're going to go to the left. So the numbers that are less than or equal to 2 would be -3, -5, -10. These are all numbers that would satisfy the inequality. And also, we could put -2 here. -2 because it's less than or equal to. Let's get rid of that. All right, next. We're going to solve and then pick our graph. So we're going to put our line down the middle. We're going to add 4 to both sides. -15 plus 4 is -11. -11 is less than -11x. We're going to divide both sides by -11. We divided by a negative, so that means we're going to have to flip our sign. So 1, instead of less than, it's going to be greater than x. So if 1 is greater than x, that means x is less than 1. So the graph that has x is less than 1 is this one. All right, I think we're at our last problem. Put our line down the middle. We're trying to isolate our variable. We're going to get rid of that 4 first by subtracting 4 from both sides. We're going to cancel it out. Bring down our n divided by 3 is less than 2. We're going to undo division by multiplying by 3. No flipping any signs here. It's going to be n is less than 6. So we're looking for an open circle, which they all have. The correct answer is the one on top, less than 6. All right, that's it for our study guide review. Come to class tomorrow with any other questions. We'll do some review before we take our test. Have a great evening.